is 8-2B, which is the 30, 60, 90 triangle. So similar to what we did yesterday with 45, 45, 90 triangles, but now obviously your angles are a little bit different. If you think about a 30, 60, 90 triangle, think about what that looks like here. Okay, you will have a 30-degree angle, a 60-degree angle, and a 90-degree angle. There is always going to be a shorter leg, a longer leg, and a hypotenuse. Your legs are not going to be the same length anymore, okay? The shorter leg is always across from which angle? Think the bigger the angle, the bigger the side across from it, right? So your smallest angle, your 30, is going to have your shortest side. So this right here is my shortest side. We're going to call it L for now, okay? Then you have your longer leg. So this is the shorter leg. Okay. Your longer leg is going to be this side, which is always going to be across from the 60-degree angle. And I'm just going to give you right now the basic setup. Yesterday it was x, x, x rad 2. I'm just going to give you today's, and then I'll explain to you how they come up with it. This side is going to be L rad 3. Okay, so instead of multiplying by rad 2 like we did yesterday, you take the shorter leg and you multiply by the square root of 3. And then the longest side, which is your hypotenuse, is just doubling your shorter leg. Okay, here's why this works. You don't need to write this part down. I'm just proving to you why we can use these shortcuts. Okay, if you want to write it down, you're welcome to, but I'm not going to go slow for writing purposes. Let's say we have an equilateral triangle, and I draw this perpendicular in, right? So this is 30 and 30 now. That vertical line just cut my bottom into 2 equal parts, right? When it's an equilateral triangle, if the length of each side is 2x, then what happened is now this is x and that is x, right? Okay, so now take that, and we're just going to look at this triangle for now. If I want to know the length of this height, sorry, let's not use h. I don't want to confuse you. It's not a hypotenuse, right? Just the height of this triangle. Let's call this z for now. I can find that right now with the Pythagorean Theorem. I can say x squared plus z squared should equal 2x squared, right? That's a squared plus b squared equals c squared. Well, if I simplify that, I get x squared plus z squared equals 4x squared. And then if I take away that x squared from both sides, I'm left with z squared equals 3x squared. So if I want to know z, if I want to know the height of that triangle, I square root both. Well, this becomes z. The square root of 3 you can't do anything with, and x squared square rooted is just x. So it ends up looking like this, right? So that means that length of my longer leg is always the shorter leg times rad 3. Okay, so this setup up here will always work, where it's L rad 3, L, and 2L. Okay, 2L is always going to be your hypotenuse. Okay, so we're just going to solve problems with that, just like we did yesterday with the 45, 45, 90. What are you doing? We're going to do that here. Here it is. This is like example 4 in the homework, if you are one that likes to follow along there. Let's say this is a 30, 60, 90, and all I tell you is this has a length of 5, okay? I'm going to just draw one of the basic setups here. You don't need to redraw this. It's just for me to refer back to with you. L rad 3, and 2L. All right. I am given here the shorter leg as 5. What would my longer leg have to be then? 5 rad 3, right? If this is L, then my L rad 3 is 5 rad 3. Okay? What's my hypotenuse? Double the shorter leg. Double my L would be 5 times 2, or 10. Okay? That's as simple as these get. You're given the shorter leg and you have to find the other two. What if you're given a hypotenuse instead? So here's a 30, 60, and 90. And I tell you that this side is 16. Can you tell me my blue line here, the one across from the 30? What? What is it? It's 8, right? If my hypotenuse is 16, this is half as much, so it would be 8. What's my longer leg? 8 rad 3. And don't mix up your rad 3s and your rad 2s. With the 30, 60, 90, it's always 3, okay? So think 30 degrees has a 3 in it. That's the one that has the rad 3. What would this one be? Here's 30. Here's 60. If I tell you this is 4, what is A? A would be 4 rad 3. That's your longer leg. What's B? 8. Okay, so those are the simpler version. Are we good on that? Okay. Where they get a little more challenging, but the good news is you did this yesterday in a very similar format. The more challenging problems of these are when they give you the longer leg. So let's say my longer leg here is 15, and I want to know what H and what K would be. Now think about it in terms of the general setup. Our general setup for a 30, 60, 90 is L rad 3, and 2L. So what is 15 right now representing? That's your L rad 3 side, okay? So I can say that 15 equals L rad 3. How do I solve for L? How do I get L by itself? Same as yesterday. Same process anyway, different numbers. You divide by rad 3. Okay, so we're going to divide by rad 3 on both sides. So this is gone. I'm left with 15 over rad 3. The issue there is you're not allowed to leave radicals in the denominator. So instead, we're going to multiply by what? Rad 3 over rad 3, right? We want to multiply by 1 because we want the same answer back. We just need to see it in a different format. So we're going to multiply by rad 3 over rad 3. And on top now, I'm left with 15 rad 3. Okay, what do I have on bottom? 3, right? It's rad 3 times rad 3 is rad 9. The square root of 9 is 3. Okay, so I do this. What does that simplify to? That is 5 rad 3. Okay, what is that? What is 5 rad 3? H or K? It's your H, right? Because this is, we just solved for L. You may plug in an H there if you want. You can put your H right here. But that side is my shorter leg. Okay, so this is my 5 rad 3. How do I get K? You double it, okay? Okay, now here's the question. How do you double 5 rad 3? You do. What?
10 rad 6.
No.
10 rad 3.
10 rad 3, right? When you double 5 rad 3, so 5 rad 3 times 2, it's 5 times 2 is 10. Your rad 3 doesn't change. Okay, so this is 10 rad 3. So 5 rad 3 for H, 10 rad 3 for Okay. Okay, yes.
Can't you just divide by 3 but add 3?
Right. Okay, so just like yesterday, right? Yesterday we were dealing with a rad 2. You could divide by 2 and attach the rad 2 to your number, right? That was yesterday. Today, the shortcut is you can divide by 3 and attach a rad 3. Now, the issue with that is yesterday it was like even or odd. You're going to get a lot of even numbers. Now it's multiples of 3 that you have to make that work. So if it's not a multiple of 3, this is just shortcut version here. Shortcut of the shortcut, I guess, technically. Let's say instead you had a number like 8 here, okay? The same rule applies. You're dividing by 3 and multiplying by rad 3 in the end, right? So you may write that as 8 rad 3 over 3, because we don't want a decimal for that, okay? If you don't remember that process, that's okay. You just solve it, okay? Plug it into the formula. Yeah?
When it's like that, and like you have to find the other side, it would be like
16 rad 3 over 3. Yep, so when you have to double this, it would be 16 rad 3 over 3. Okay? Let me show you one more time where you're actually solving it out, just because I don't want you to have to rely on remembering a shortcut, in case some of you don't like to use the shortcut. So this is a 30, 60, 90, and let's say this is 11, okay? I know in a 30, 60, 90 that my longer leg, which is what I have, is my L rad 3 side, okay? So if 11 is L rad 3, then if I'm going to solve for my my shorter leg, my L, I would divide by rad 3, which gets this out of there, and then I would multiply by rad 3 over rad 3. So I have 11 rad 3. Rad 3 times rad 3 is 3, right? That's rad 9, which is 3. So this would be my shorter leg, okay? But like I said, you can go from here straight to here. If you remember, I'm multiplying by rad 3 and I'm dividing by 3. That's fine. I don't have a problem with you doing that because it will look like that every single time, okay? Just know that if it's a multiple of 3, then actually divide it. Like if this number was 12 instead, then you would do 12 times rad 3 divided by 3, which means you're actually getting 4 rad 3.
So
Okay?
if it's not a multiple of 3, you just leave it the way it is.
If it's not a multiple of 3, it's going to look like this.
Gotcha.
Okay? What would your hypotenuse be?
22 rad 3 over 3.
Right. 22 rad 3 over 3.
Wait. Oh, it's long. Okay.
Oh, times 2.
This is your hypotenuse, right? Across from the right angle. So you're taking that 11 and you're doubling it. 22 rad 3 over 3. No. I said if I were to give you a different number, different problem. Okay? Last one. And just make sure you're paying attention. Notice all these triangles look different. They're all 30, 60, 90s, but they can be laying on a side. They can be flipped around. Pay attention to how they're set up, right? Let's say I give you 24 right there. What is A and what is B? A would be 12, right? If that is 24, that's my hypotenuse. That's doubling my shorter leg. So cut that in half. A would be 12. And then what would B be? 12 rad 3. Okay? Questions? Isn't that fun?